This lesson is on similar polygons and dealing with the ratios. The main thing that you're looking for is if polygons are similar, they're going to have a same shape, but they're not necessarily going to be the same size. They can be the same size, but they're not necessarily going to. So if you look at this one here, it kind of gives you just a basic idea. One is similar to 2 because they have that same basic shape. If we actually took a protractor to this, we'd find out that the corresponding angles would actually be congruent. Looking at this one here, 1 and 3 are not going to be similar because here we've got a right angle and this is not isosceles and this is an isosceles triangle, so these cannot be similar. So just remember that idea of the same shape will give you those similar polygons, but more or less this is what you're looking for. If you have two polygons that are similar, then that means the corresponding angles have to be congruent. So the angles that go together, so like if you look here, angle A and E go together, so those two would be congruent. B goes with F, those two would be congruent. C and G are corresponding, those would be congruent. D and H are corresponding, and they would be congruent. So the corresponding angles would have to be congruent. And then one more factor. The sides have to be proportional by the same scale factor. So like if you look at this one here, 6 over 12 is the same as 5 over 10, which is the same as 5.4 over 10.8, which is the same as 4 over 8. And all of those would reduce to 1/2. So what they're saying here is this side AB over side EF would be the same or the same, equivalent to AD over EH, BC over FG, DC over HG. So a bunch of different ways that we can say this, but basically if they're similar, the corresponding angles have to be congruent, sides have to be proportional. Here we see they're proportional by the same scale factor. So I'm going to skip this example here. So we're going to decide if the polygons in this example here are similar. If so, we're going to write a similarity ratio. If we're going to see if they're similar, what you're looking for is you want to make sure that the sides are proportional. We want to know if 6 over 4 is the same as 9 over 6. And so we can simplify this here. If we simplify that, that gives me 3 to 2, because I can divide a 2 out of both of those, and I can divide a 3 out of both of these, which would give me 3 to 2. So yeah, they are actually similar. And so our ratio here that we're going to be dealing with to get from here to here is really like a reduction, a dilation, but we're dealing with that ratio of the 3 to 2 something, 3 units to the 2 unit measure from one to the other. Now, let's get these, Getting into problems like this where you have a model, with the model, you can solve something like this. If you know that they're similar, remember those sides are going to be proportional. When you have a model, the figures are going to be similar. It's that idea of congruent angles, proportional sides. So on something like this, if you're trying to solve for x, set up a proportion. All right, and I want you to see how I'm going to set up this proportion. I'm going to put the model on the top and then the actual on the bottom. So this would be true. The model over the actual is equal to the model over actual. So what we're going to do then is we're going to just pick a side here, like this side right here. This is on the model. So I'm going to say this side is 6.3 over what side corresponds with this on the actual racing car? This one, the 1.8. So this was 6.3 centimeters. This was 1.8 meters. And that's the model to the actual, the model to the actual. Now set up another proportion. The model on this length of the car is x. Notice I'm putting the model on the top. And then the actual racing car is 5 meters. So what we're going to do is I'm going to go ahead and drop the units. We'll deal with those at the end. But you're going to just solve this as a basic proportion. Cross multiply. We have 1.8x is equal to 5 times 6.3. And then you can whip out your calculator to help you with some of these calculations. So we have 5 times 6.3. And so we get 1.8x is equal to 31.5. And then I'm going to actually divide those sides by 1.8. So we'll take that answer, divide by 1.8. And x is going to be 17.5. Now pay attention to the units. This x is on the model. What unit are we dealing with in the model? We're dealing with centimeters. So we've got to have 17.5 centimeters. So that kind of gives you a basic preview of similar polygons.